To solve a quadratic inequality, we really just need to know two things. Number one, we need to know if the quadratic opens up or down, and then number two, we need to know the x-intercepts. From there, we can just look at the graph to determine our solution set. If you're given a graph, like we have in this first example, there's really no work to be done. We just have to look at the graph and understand what is being asked. In this first example, A, we're asking where is the quadratic less than 0? In other words, where is the graph below the x-axis? So here is where it is, below the x-axis, where it's less than 0. Notice all of the y values in this section are below 0, or they're negative. So that occurs from 0 to 5. Notice that we need to be strictly less than 0 in example A. In example B, we're basically asking the same question, but we can now have equality. So now we're asking where is the quadratic, or where is the graph less than 0? Where is it below the x-axis, but also equal to? So we can have equality on those endpoints. That gives us the brackets. In example C, we're asking where is the quadratic greater than 0? In other words, where is it above the x-axis? This piece here, this tail end, is above the x-axis. That is from negative infinity up to 0. And we also have this tail. Notice this tail is above the x-axis. So we have 5 to infinity. And D is asking a very similar question, only now we can have equality. Where is the graph above the x-axis or equal to it? Again, equal to 0 means we include those endpoints. Negative infinity to 0, including it, and including the 5 to infinity. In this example, again, just a different graph. There's no work. All we have to do is read the graph. Where is the quadratic less than 0? In other words, where is the graph below the x-axis? This tail is below the x-axis, and this tail is below the x-axis. So on the left, we have negative infinity up to negative 2, union, the right tail is 3 to infinity. And B, the only thing that's different here is we can include those endpoints. We have equality. So in this example, we have negative infinity to negative 2, including the negative 2, and including the 3 to infinity. In C, we're asking where is the quadratic greater than 0? In other words, where is it above the x-axis? So from this point all the way to this point, we have the graph is above the x-axis. We cannot include the endpoints for strictly greater than, so we have negative 2 to 3 in parentheses. D is now including those endpoints. We have equality, so we can bracket the negative 2 and the 3. This time we have two separate functions. We have a quadratic and a linear function. Keep in mind which one is which. F is the red quadratic, G is the blue linear function. Again, you're given the graph, so there's no work to be done. We just have to read the graph and understand what the question is asking. Here we're asking where is the F greater than G? In other words, where is F above G? F, again, is the quadratic. So reading left to right, the red quadratic is above the blue here, right? Notice the red is above the blue here as well. The red is above the blue. So that occurs in this interval from negative infinity up to negative 2. And on the right side from 1 to infinity. Notice again, we're not including those endpoints because of the strict inequality. Question B is asking the same thing, but we can have equality. Where is f greater than g? In other words, where is the quadratic above the line? That's happening from negative infinity to negative 2, including the 2 this time, and including the 1 to infinity. Next, we're asking where is f less than g? In other words, where is the quadratic f below g, the line? Where is it below? In this region. Notice the red graph is below the blue line. That's happening from negative 2 to 1. Or example D, if we're including those endpoints, since we have equality, we can bracket the negative 2 and the 1. Again, recognize that f is the quadratic in this example and g is the line. So where is f greater than g? Where is the quadratic above the line? The quadratic is above the line here. That's occurring between negative 3 and 1. Notice we go from negative 3 to positive 1. The graph of the quadratic is above the line. F is greater than g. B is very similar. We're still asking where is f greater than g, but now we can have equality. That means we can include those endpoints. So bracket negative 3 and 1. In example C, we're asking where is f less than g? In other words, where is f, the quadratic, below the line? Here, the quadratic is below the line, and here, the quadratic is below the line. So just list those two intervals. The interval on the left is negative infinity up to negative 3. And on the right, we're starting at 1 and going to infinity. In D, we're asking the same question essentially, where is f less than or equal to g this time? The only difference is we can include the endpoints. So negative infinity up to negative 3, including that endpoint, and including the 1 to infinity. So in those examples, you didn't have to do any work because you're given the graph. You just have to look at the graph and understand what you're looking at. In the next example, we have to do a tiny bit of algebra. So notice here, we're not given the graph. So the only thing we're going to do here is sketch the graph. And from there, basically do what we just did. There's two things you need to know. You need to know whether the graph opens up or down, and you need to know where your intercepts are, the x-intercepts. So here we know that the graph is opening up because a is positive. You have a positive 1 here. Now we need to determine the x-intercepts. To do that, let's just factor two numbers that multiply to negative 10 and add to negative 3 are negative 5 and 2. Always take a second to double check those. Negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3. Take 2 seconds to double check that. And then we set each factor equal to 0 and solve. X equals 5 and x equals negative 2. Those are your x-intercepts. So off to the side, we're just going to very quickly sketch our graph. It doesn't have to be crazy accurate. We just need to know basically what it looks like. we're going from -2 to 5, and we know that the quadratic opens up. Again, we don't have to be crazy accurate, just get a general idea as to what this looks like. And now you have essentially what we had a few moments ago. You have the graph. Once you have the graph, you just have to look at it and make sure you answer the question. In this case, the question is, where is the quadratic less than 0? Where is it below the x-axis? That's happening between -2 and 5. It is below the x-axis. Notice we're not including the endpoints because of the strict inequality. In the next example, we need to find the x-intercepts. First, we'll add 4 to both sides. Take the square root of both sides. And remember, when you take the square root of both sides, we need to get the plus or minus. Square root of 4 is 2, and -2 because we took the square root of both sides. So those are your x-intercepts. Again, very quickly sketch those. You have -2 and +2. And now ask yourself, does it open up or down? A is 1 here. That's positive, so that means it's opening up. Again, we don't have to be crazy accurate, just a very quick sketch so that you can see the general shape of the graph. And now we're asking, where is the quadratic greater than 0? Where is it above the x-axis? That's happening here and here. Notice we're strictly greater than. We can't include our endpoints. So we're above from -infinity to -2 and from 2 to infinity. In the next example, notice that we need to first set it equal to 0. So I'm going to subtract 5x and subtract the 3 so that the right side is 0. And now find your x-intercepts. In this case, we need to use the AC method because A is not 1. So A times C is -6. Again, 2 times -3 is -6. What two numbers multiply to -6 and add to -5? That would be -6 and 1. So we're going to rewrite the original quadratic, 2x squared minus 6x plus 1x minus 3, and we'll say it's equal to 0. From here, factor by grouping. Looking at the first two terms, their GCF is 2x. Factor that 2x out, we're left with x minus 3. The last two only have a 1 in common, so we'll factor out a 1. We're left with x minus 3. Notice the parentheses are the same. That's an indication that we're on the right track. So factor out that GCF again, and we're left with x minus 3 times 2x plus 1. From here, we can see that the x-intercepts are 3 and -1/2. Graph that. We have -1/2 and 3. We know that the quadratic is opening up. So again, quick sketch. Doesn't have to be crazy accurate. We just need a quick sketch so that we can now look at the graph and answer the question. So here we have, where is the quadratic less than 0? In other words, where is it below the x-axis? It's below the x-axis from -1/2 to 3. We'll use parentheses because we are strictly less than. We cannot include those endpoints. Next, we have this quadratic. Looks like A is 1, so we can try to factor, but there are no two numbers that multiply to 4 and add to 2. I can't think of any two numbers that will multiply to 4 and add to 2. So in this case, we may need to use a different technique. If factoring doesn't work, your go-to is always the quadratic formula. So let's try that. We have negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Simplifying will give us negative 2 plus or minus the square root of 4 minus 16 over 2. That is negative 2 plus or minus the square root of negative 12 over 2. Now this can be simplified a little bit more, but we don't need to keep going. And that is because of the negative under the radical. Remember, whenever you have a negative under the radical, that means that this is an imaginary number. And imaginary numbers are not real. So what that means is there's no x-intercepts, right? This is not real. Therefore, no x-intercepts. If there are no x-intercepts, that means that this quadratic lies either entirely above the x-axis, or maybe it lies entirely below the x-axis. So you have to ask yourself, which one is it? Is it always above or always below? Again, ask yourself, does it open up or down? In this case, a is 1, so we know it opens up. That means it has to be entirely above the x-axis. We don't know exactly where. It doesn't matter. That's okay. We just know that there are no x-intercepts, so it's either got to be all above or all below. In this case, it's always above the x-axis because a is 1. It opens up. So now we have to answer the question. Once we have the graph, and again, the graph doesn't have to be crazy accurate. You just need a general idea of what it looks like. From here, we can answer the question. Where is the quadratic greater than 0? Well, everywhere. It's always greater than 0. It's always above the x-axis. So it's always above the x-axis, then our answer is everything. Negative to positive infinity. The graph, the quadratic, is always greater than 0. In the last example, again, notice that we need to make the right side 0. So I'm going to subtract 6x from both sides. And now, since a is not 1, right, we have a 4 here, we need to use the AC method. AC is 36. What two numbers multiply to 36 and add to negative 6? If you don't see it right away, list the possibilities. 1 times 36, those multiply to 36, but they don't add to negative 6. How about 2 and 18? They multiply to 36, but they don't add to negative 6. 3 and 12. They, again, multiply to 36, but they don't add to negative 6. 4 and 9, they multiply to 36, but they do not add to negative 6. So then we have 6 and 6. 6 and 6 multiply to 36, but they don't add to negative 6. So it looks like the AC method is not going to work here. So if factoring does not work, then our go-to is the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. So from here, just simplify. We get 6 plus or minus the square root of 36 minus 144 over 8. That is 6 plus or minus the square root of negative 108. So again, this can probably be simplified, but we don't need to. We can see that the radicand is negative, which means these are imaginary answers. Again, these are not real, these are imaginary, which means there are no x-intercepts. If there are no x-intercepts, then the graph lives entirely above or entirely below the x-axis. So again, let's just get a quick sketch. We don't have to be crazy accurate. Which one is it? Is it above or below? Look at your quadratic here. A is positive, which means it's opening up. So we know it opens up and it's somewhere above the x-axis. Again, we don't have to be crazy accurate. We just know that it's opening up and it's above the x-axis. So once you have the sketch, you can look at the inequality and ask yourself, where is the quadratic less than 0? In other words, where is it below the x-axis? It's never below the x-axis in this case. So if it's never below, in this example, our answer is no solution.